So the part of today's section, what we are going to learn across is about how do we deal in case a disaster recovery happens or a disaster is going to happen. How are we going to help with the recovery? And in the second case, we are going to see how can we actually improve the performance of any RDS database system. So let's quickly move into the slide section. Yeah, before we move to the next part, one more most important thing that you have to always remember: if you are trying to restore the database either from an automated backup or from a manual snapshot, it doesn't matter, but the restored version of the database will always have a new endpoint. So in case if you are already having a web server or from anywhere else, you are trying to connect to your database, you will have to update your endpoint. And talking about a little bit on encryption. Encryption at rest is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, all of the databases, but this is available only for the database of the higher sizes. You will not be able to see the option of encryption which is available. If you have remember, it was grayed out in our case because we were trying to use a part of database for the free tier. If it is ahead of free tier, like if I have a database size of like M1 large something as such, then I'm all going to get this portion of encryption automatically enabled, and I'll be able to see whether I want to really opt for it or not. And encryption is usually done using the AWS key management services, that is KMS. And once the RDS data is encrypted at rest, the underlying storage is also encrypted, as are its automated backup, read replicas, and the snapshots. So if your database is encrypted, then all the snapshots, whether it's a manual or whether it's automated, whether it's a read replica, everything gets automatically encrypted. And if you already have a database instance on which the encryption is not enabled, then it is really difficult to get any existing instance to be encrypted. For that, you have to go ahead and first take a manual snapshot and then start migrating the data into the new one. So it's a little pain point to go ahead and encrypt an already running database instance. Now, talking about the disaster. So we all know that yes, disasters can happen. So what can we do in this specific case? So this is the reason databases are being designed in a point with multi-AZ concept. So we all know that Amazon is really working hard to make the things better. So in every region that we already have available across the world, there are minimum 2 availability zones, which means if even one of them goes down, the other would be still available to serve the data. So they are trying to create this multi-AZ concept. So now database, whenever we are going to launch, usually it is part of a single availability zone, and we do get an option of multi-AZ. So what happens in the multi-AZ? There are 2 different copies of my database that gets created, right? So if I'm trying to create in the US East 1A, so here the terminology of naming is a little different. So usually I have 6 availability zones in the US East 1, that is North Virginia. So let's say I'm trying to create the database in US East 1A, and when I say it to be a multi-AZ, it can automatically create one other copy in the US East 1B or 1C or 1D or 1E or 1F, and then there will be 2 copies of my database. This is a web server. Let's say the people are trying to connect to my web server from the load balancer, and the load balancer is connected to 3 different EC2 instances, and these instances are actually talking to one of the database in the multi-AZ concept. Now whenever we are going to choose for the multi-AZ concept, you will have one of the database as a master and the second one as a slave. So here all the connections would be first redirected to the master. In case, let's say one of the availability zone goes down, so the other one would be still available for me to serve the connections. So I don't have to update any endpoint in these web servers. It automatically makes all the transactions with the standby database. So the now standby will become a primary database in this case until this comes up. So this is how the multi-AZ concept is going to help us. So even if one of the availability zone goes down, automatically all the transactions are being redirected to the another database which is in separate availability zone. Now, whenever you create a multi-AZ database, all the replication between the master and the standby database is automatically taken care by Amazon. We don't have to worry anything in terms of replication, how is it going to happen, how is the data is going to get synchronized. Everything is being taken care by the Amazon. And even the endpoint, I don't have to change anything as such. Automatically, if this database goes down, these web servers will start communicating with the one that is in the standby database. So the multi-AZ concept is really more about for the disaster recovery. So what happens in the multi-AZ? Multi-AZ allows you to have an exact copy of a production database in another availability zone. AWS handles the replication for you. So when your production database is written to, all the writes will automatically be synchronized to the standby database. Now, in case if you're trying to have any planned maintenance for the master database, or in case if there is any database failure, or in case if there is any about the multi-AZ concept of our RDS, what does it do and how does it help us? So multi-AZ actually allows you to have an exact copy of your production database in another availability zone. So we usually have minimum of 2 availability zones in each region. So wherever I go and put across the RDS as a multi-AZ, automatically 2 copies of my database will get created. But unlike the S3, where I have multiple copies of the same object, I'm not sure which copy I'm going to get connected to in the backend. If it is a S3, let's say I'm trying to use Tokyo region, which has got 3 availability zones. So moment I'm going to store a object on the S3 standard, automatically 3 copies of my object will be created in the 3 different availability zones. And whenever I'm trying to access an object, I'm never sure which availability zone I'm trying to access this object from. But in case of multi-AZ RDS, usually there will be multiple copies, but it will be in terms of which one will be a master copy and which one will be a standby, right? So we always connect to a master database until unless if there is any problem with the master, when it goes down, only then the standby database is a place where the connections will automatically redirect to. So as we just looked in one of these examples here, so if the master goes down, only then automatically these connections are going to get redirected towards the standby database, and we don't have to worry about the synchronizations, the replications. Everything is taken care by the Amazon. And in event of any planned database maintenance or any database instance failure, or if the availability zone failure is going to happen, Amazon RDS is automatically going to fail over to the standby so that the operations can resume quickly without any administrative intervention. So we do not need to have any administrator to take care about this. Automatically the things would get redirected towards the standby database. Now yesterday, if you remember, we were having one point called as clusters. Now what does happen in the clusters? So you can basically define your own cluster here by having a multi-AZ database. So now let's say I have chosen 2 different subnets. So here we actually have something called as subnet groups. Now if I go down and say I want to create a subnet group, I'll just say test subnet, and in this again I'll just give you same. So currently we have the default VPC here, and then it is going to ask me what all availability zones would you like to include. Let's say I just want to include one E here and then one F. I'll just say add subnet. So these are the 2 subnets that I would like to go ahead and put across, or you may also select one more if you want to. Right, so you can put across any number of subnets. So for now I'll just keep it simple by putting across 2 subnets, and then I'll just say create. So this has now created a subnet group. Yeah, so we just created a test subnet group. So by default, one of the subnet group with the name default will be always available. So we just created one of them with a test subnet which has got 2 availability zones. Now if you remember, when we were trying to launch a database instance, let's try to do the activity part here. Here I'll say create a replica in different availability zones. So let's pick up for multi-AZ option, and then I'll just go down here. I'll just give some random name. We are not going to launch anyway. We're just going to check out what are the options we are going to get across. Here, now if you see the first portion where we see the network and security, you are also able to see something called as subnet. So here we can actually go ahead and select the test subnet. So when I select the test subnet, automatically it is going to deploy it in two different availability zones, and that too I have selected which availability zones it should be. It should be only 1E and 1F. So those are the two availability zones in which I would like to have this database to be a part of. Right? So the subnet groups actually help you with a choice of your own availability zones in which you want to keep it across. So when we are going to learn about the VPC section, we are going to learn in detail about what is a subnet, what can we do more about it. But for now, remember, Amazon has created one subnet per availability zone. So if it is a Mumbai region, I have two availability zones, which means I will have two subnets. If it is a North Virginia region, I'll have 6 availability zones, which means I'll have 6 subnet groups, right? So here I get a choice of which subnets I want to put it across with. So in this subnets, I have defined which are the availability zones which are going to be picked up. So this will be 1E or 1F. Now, there was another point that we were trying to discuss about it yesterday, that is cluster. Now, when we know that it is actually going to launch two databases in two different subnets, that is 1E and 1F, now you want to define which one would be a master. So that option we actually get to see it in the cluster. So cluster is the option that you will be able to see it here. So when you go down here, you will be able to, the moment you are going to create a multi-AZ database, it is going to show up the cluster here, and in which you will be able to select out which one is going to be the master and which one is going to be a standby. So you also have an option to define out that the database in the availability zone 1E is going to be the master and the 1F is going to be a part of standby database. So those are the things that we can actually do with the clusters and the subnet groups here. And remember, multi-AZ is only for the disaster recovery. So if something happens, yes, multi-AZ is required for the clusters. So multi-AZ is all about disaster recovery only. So if something happens really for my database, in that case itself, I'm trying to use the multi-AZ. So if I want to improve the performance of my database, multi-AZ is not going to help you. So for performance improvements, you need something called as read replicas. Now, what is a read replica? So that is the next thing that we are going to learn across. Before that, multi-AZ databases are usually available for SQL Server, Oracle, MySQL, PostgreSQL, and MariaDB only. It is not available for Aurora, because Aurora automatically comes with multiple copies. So the moment I'm going to create Aurora, 6 different copies of the databases are going to get created. So that is something specialty about Aurora. So we are going to learn in detail about Aurora as well again. So in terms of the database section, where we have 6 different database engines, that is SQL Server, Oracle, MySQL Server, Postgres, Maria, and the Aurora. Out of this, multi-AZ concept is available only for 5 of them, that is SQL Server, Oracle, MySQL Server, PostgreSQL, and the MariaDB. So Aurora DB is not part of multi-AZ databases because it is little special, and the moment I'm going to launch the Aurora, it is automatically going to create 6 different copies. So that is everything managed by Amazon. And now talking about the performance improvement in terms of the read replicas. So we all know that whenever the database is being created, after that we start storing the transactions. Now let's talk about one of the leading e-commerce websites. So let's say I go ahead and order in the flipkart.com something today at 10 in the morning. Once the order has been placed, I would be usually curious about when that order is going to be delivered. So what is the status of that specific order? So we usually go back to our account and we usually keep checking whether the status of the order has been changed or where is it being struck, if it is so. and if it is as a delivery point, who is the person who's going to give me delivery, or at what point of time I'm going to get this product delivered on so and so date, right? So once the right transaction has been completed, like once I place the order, the next activity will be always I'll always keep a track of it, right? So whenever I'm going back to the same e-commerce website to check out the status of the order, it is like I'm trying to hit a read request onto my database in order to retrieve the information. So every time I open the order details, it is going to put across a read request to find out the details about my order. Now imagine 10,000s of transactions happening in 1 hour on this e-commerce website like Amazon and Flipkart, and out of those 10,000, at least minimum of 5,000 users are going to come back at the same time to check out what is the status of the order. So you have 10,000 transactions in terms of writes that are happening per every hour, and you are adding upon 5 to 6,000 of read transactions every hour, right? So your database is being heavily used in terms of reads and the writes. So can we improve the situation of this database? Yes, we can improve the situation. What we can do is we can actually create a read replica. So what does a read replica do? I'm trying to create a same copy of my main database, and I'm trying to put across as a read replica. So in read replica, I'll be only able to read the data from this. I'll not be able to write any data to this. So now whenever any user is trying to come and read through the database, any transaction to read through from the database, they will be automatically they'll be always fetching the data from the read replicas instead of the main database. So the main database, I'm just utilizing it for the write purposes, and the read replicas are the place from where I'm going to go ahead and read the data. So this is going to improve the situation for me very heavily. I can also have a read replica of the read replica, but yes, of course, the synchronization is going to take a little while, so I'll have to watch out for the latency in case I am going to have a read replica of the read replica in this case. So what can we do with the read replica? It actually allows you to have a read-only copy of your production database, and this is achieved by using a synchronous replication from the primary RDS instance to the read replica. You can use read replicas primarily for the very read heavy database workloads. Now sometimes it also happens that I'm working with a management team, and my management team will always ask me what are the number of transactions that happened during the last 1 minute, what are the number of transactions that happened in the last 10 minutes, what are the number of transactions that happened during the last 1 hour. So I'm also going back and hitting on the database to find out all this data. So basically I'm trying to read the data, I'm trying to put some select queries, trying to fetch the data and find out how many orders were placed, how many were cancelled, how many were put across for the replace of a repair or something as such. So I would like to find, my management team wants me to find out. So if I'm trying to hit the main database and get all these details, it is like I am trying to consume the CPU cycles of this. So what usually people do in the real time is they create a read replica of the exact production copy, and the size of the read replica is usually much more heavy than the normal database, because the normal database we are just going to utilize it for the write purposes, and the read replica are something where I'm going to put across all my queries like my management would like to give me across in terms of getting the data for generating analytics, right? So we can actually use a read replica which can actually improve the performance of my databases heavily. And the read replicas are currently available only for these three, that is MySQL Server, PostgreSQL and the MariaDB. Aurora, as I said, it's exceptional. We do not need anything as in terms of multi-AZ or read replicas, but in terms of read replica, Oracle and the Microsoft SQL Server also do not give any support. So we are unable to put across the third-party companies softwares like Oracle and the Microsoft SQL Server for the read replicas. And few important points to remember here: whenever you are going to make use of read replica, remember it is just used for scaling the database up, which means in order to improve the database, it is not for the disaster recovery. If you are thinking about the disaster recovery, you always need to go for multi-AZ concept. And in order to have a read replica, you must have the automatic backups turned on in order to deploy a read replica, right? So if you want to really have a read replica, you must have to mention the backup retention period with at least some number of days, minimum of 1 day and maximum is 35. So you have to mention some value in that backup retention period, so which will enable the automatic backups, and that will help me to put across it read replica. You can have up to 5 read replica copies of any database. So maximum is the 5 that we can create, and we can also create a read replica of the read replica, but just that you have to watch out for the latency. And each read replica will have its own DNS endpoint. That is really important. Now if I have 4 read replicas like as shown in this figure, all these 4 will have different endpoints, and you cannot have a read replicas that have multi-AZ. Here this point actually means, let's say I have got a primary database and a standby database in terms of multi-AZ. I will not be able to create read replica for the standby database. However, it says here in the next point, you can create a read replica of multi-AZ source database, not the standby database. So we will not be able to create a read replica for the standby, but for the primary or the source database of a multi-AZ, we will be able to create a read replica. And read replicas can also be promoted to be their own databases, and this breaks the replication. So if you think you want to go ahead and create a read replica and now you want to deploy some other application and you want to use the same database here, so you can actually go ahead and promote this read replica itself to be a own database. But whenever I'm going to promote it to be a own database, which means I'm enabling the write transactions as well apart from the read transactions, right? So this is going to actually break the replication. And the read replica in second region is actually possible for the MySQL and the MariaDB, but not for the PostgreSQL. So you can actually create the read replicas in another region as well. So this actually gives a very good flexibility. Let's say my company's headquarters exist in US and we are working from the India. So as per the Indian government rules, we should have all the data to be residing in the servers which are in India itself. So now that the Amazon has actually opened up the data centers in the India, in the Mumbai region, let's say I start deploying everything on the Mumbai region, but since my headquarters are still in US and they would like to generate some reports or something as such, it sometimes becomes difficult because they have to send their request all the way from the US to Mumbai region, and since the regions are a little far, there could be a latency in order to access the data. So what you can do is you can always create a read replica copy of a database, if it is a MySQL or a Maria, and into the different region itself, and so that your management, wherever it is sitting, they will be able to directly connect to the database which is in their region. That is a read replica copy, and from there they will be able to easily generate the analytics. Now talking about the one last part about the RDS here. So in terms of RDS, what happens? Now let's say if I want to increase the size of database, or in case if I would like to restore the database, or if in case if I make some changes to the existing database, so it is actually going to take a little while. I cannot have my RDS up and running all the time. I need to get it down for a little time. I'll create a snapshot, and then from that snapshot I'll try to create a copy which is of higher size. Or in case if I want to make some changes, let's say there's one table in which I would like to add extra column, and then we need to set up the indexes or something as such. So once we do all those things, we need to again restart the existing database. So again, it is going to have a downtime, right? So RDS is not so easy, and usually have to use a bigger instance or need to have a read replica and all also to improve the performances and do all those things. But when we talk about the NoSQL DBs like Dynamo, you do not have any downtime, and it is basically a push button scaling. So if you think you want to increase the size of a database, if you think you want to improve the performance of a database, it is just a push button scaling, we can tell it about, right? So I just go to my button and say that, okay, I want to increase the size, I want to increase the capacity. you can just do it within fraction of seconds while the database is still live running in the production environment. So that is possible with NoSQL, DynamoDB, but not with the RDS, right? So that is the difference that we are going to see across how the DynamoDB is actually going to offer me push button scaling, where I can scale my database up without any downtime.